Hi there, my name is Benedict Steiner and I'm an exploration geologist. Today I'm near Timmins, Ontario in Canada, and I would like to talk to you about the importance of Quaternary geology in geochemical exploration techniques. The Timmins area is very well known for its very large base metal and gold deposits in the western part of the Abitibi greenstone belts. Geochemical exploration techniques have always been very important in locating mineralization and ore deposits. However, in the northern hemisphere we have had a number of glaciation periods in the Quaternary, so the recent geological past, and these the products of these glacial erosional phases, they are complicating interpretation and the interpretation of geochemical surveys. Why is this? Well, unlike in other areas such as the tropics where you get residual lateritic deposits, here in the northern hemisphere glaciers have moved and transported the eroded products, bedrock products, across quite large distances. And therefore it's very important to understand what you have sampled and what implications this has on the interpretation of geochemical signatures. So why are orientation studies important? Orientation studies help you to determine the most important factors that influence your later geochemical sampling program. In formally glaciated terrains, such orientation studies include a few more aspects which I would like to quickly summarize here. First of all, you need to understand what type of material of glacial erosional products you're sampling. And you can do this by looking at the Quaternary geological maps published by the respective geological surveys, or you can start pulling a number of trenches and test pits in order to test and describe the overburden stratigraphy. So depending on the area you're at, you can distinguish a number of glacial landforms such as drumlins, moraines and eskers. All of these glacial landforms have different so-called transport distances, which indicate how much the glacier has moved this material when the glacier advanced or retreated. Eskers, for example, are subglacial drainage channels which have transported coarse material over very long distances. So we're talking 30 to even 50 kilometers. In Canada here, you can check it out on the Quaternary geological maps. They have transported material for even hundreds of kilometers. Now this is of course problematic if you're sampling this type of material, because you have probably no clue where the geochemical anomaly or signature is coming from. This is different in a number of moraines which usually have migrated only for a limited amount of kilometers. So understanding the type of material you're sampling is highly important. Second, you need to consider what part of the overburden stratigraphy you're sampling. You can either sample close to the bedrock contact, and that will allow you to sample material that has probably been moved only a minimal amount, or you can sample higher up in the overburden stratigraphy with the problem that the higher you go in stratigraphy, the more glacial smearing you will experience. You can also sample, however, the organic material, so the upper parts of the soil that you see around here. Now all of these have pros and cons, and it will determine, and your orientation study will determine which part of the stratigraphy is the best to do. For that you have to subsample a number, a transect through the overburden. Also, you would need to consider the analytical techniques that are of importance when digesting and analyzing the glacial material. So my preferential technique is, when I'm using a bottom of till sample, is to use what's called 4-acid digest and a multi-element ICP-MS technique. And this is because I can not only determine geochemical anomalies, but I can also try to fingerprint the bedrock that this sample constitutes or has been eroded from. However, companies also use what's called aqua regia digest, and that's quite a weak acid leach that's predominantly giving you or digesting the sulfides and free gold for you. A bit higher up in the overburn stratigraphy, you may also want to employ weaker digests, such as proprietary techniques, mobile metal ion or ionic leaches. You can get these from some commercial laboratories. If you sample the topsoil, you would want to investigate weak leaches, because metal ions usually migrate through the stratigraphy, are basically absorbing to this organic matter. However, if you sample in very sand-rich overburden, for example, material from glacial outwash sands, the sand and the quartz is diluting your sample. So the ideal material to sample is silt or silt or clay. Sorry. So we've talked about in this video the importance of understanding the glacial overburden, the material you're looking at, the analytical techniques you're using, and what material is literally the most ideal to send back to your labs. All of this is really depending on the specific location you're in, and that's why it's requiring an orientation study. I hope you enjoyed the video, and if you like it, give me a thumbs up, and I'd be happy to answer any questions down in the comment section. Thank you.